Hello, everyone.
Everyone,
Yeah, hey, William.
Scott, Bowen,
Okay.
Yeah, my name is Boian Mitov, and I'm the creator of Visuino. And we already had one session when I presented the basic functionality of Visuino. And again, Visuino has effectively three versions. There is a completely free version, there is a standard version, and there is professional version. And while the standard and the free versions are designed for the average folks and beginners, students, artists, makers, people of that nature, the professional version is targeting the mainstream industry. And one of the areas where it excels is industrial automation. In this session, now we'll focus more on the industrial and automation functionalities and the capabilities of Visuino Pro. I will quickly go over some of the other Visuino Pro features. So we'll start by sharing the screen. Hopefully I'm sharing the right screen and everybody can see it. Oops, yeah, I'm sharing the right screen. Is that where I'm pointing with the mouse at the moment? Can you guys see it?
I see it, but it's very small.
So I hope I'm sharing the right screen.
I see a blue box
Yeah, okay.
and it says Adreno on it.
Yeah, that's it. So I'm sharing the right screen. Unfortunately, that's the best I can do. I'm trying to, let's see if the other screen is better. Let's stop this share and start sharing another screen. Yeah, I'm trying to figure out which screen will work better. Okay, what if I change display settings? Yeah, I'm trying to find option that will work fine. So if I share, let's see if I share this screen. Sorry about that. Yeah, it's improvised situation here.
I'll cut my camera off so the bandwidth goes down.
1 second. Trying to share. Come on. Okay, let's try sharing this screen. Is this screen better now? Is it easier to see here?
If I get really close, I see digital, analog, digital.
No, I think we'll go back to the other screen.
Okay.
I think it's better, yeah. Sorry, I'm trying to figure out which screen is better to share. So let me rearrange everything back in place. Unfortunately, when Zoom is doing captures and stuff, the system starts to work quite slow.
Although it's my opinion that analog doesn't really exist.
Okay, so yeah, no, I'm still comparing the two screens. Okay, we'll share the second screen. I think it's better. Sorry about that. Yeah, I was trying to find a better way to share, but that's going to be the way it is. So, in any case, wrong screen. Yeah, I'm trying to organize my workspace here for the presentation. And the computer is not cooperating with me. Okay. This thing here. So hopefully you guys can see the screen I'm sharing.
Yes.
Okay. I want mouse. I don't want to. Okay. This is Visuino Pro. And when you start it, of course, you have the Arduino board as with the standard one. Now, Visuino Pro also has live code where you see the code as you're changing the design. I'm not going to go through the full Visuino explanation. We did that in the first video. You can watch the replay. But other features, how to move this annotate stupid thing out of the way. Well, so other features are you can have sub-diagrams. So you can add components, let's say, here in a sub-diagram, and you can add some pins to the sub-diagram of variety of types. And of course, design your diagram. And then here, when you go to sub-diagrams, you can use the sub-diagrams in the main diagram, and you can create subdiagrams that contain other subdiagrams, and so on and so forth. So basically hierarchy of sub-design. So that's another feature of the Visuino Pro. In addition, Visuino Pro has industrial control functionality, which we'll see shortly. And it also has Fourier transformations and other components, which we will not have time to cover today. To go faster, now I have also prepared a camera where I can show different controllers. So when we talk about industrial control, we talk about controllers like this, variety of types. And they sometimes may look like this, or something like this, or this which I got on AliExpress, or it can be even something as small and miniature like this little, basically temperature sensor, which is Wi-Fi connected temperature sensor, which you can put somewhere and collect data. So this is in terms of how the hardware may look like. And this is designed to be used typically for home automation or industrial environment. This example is specifically designed for industrial environment, and as such is rated and a bit more expensive controller. And this is what we will use for our first tutorial. So we'll start by selecting the board as Maxi, Controllino Maxi. It's Swiss made in Switzerland, if I remember correctly. To connect, first of all, let's add some sensors to it. And I have added pressure and temperature sensor, I2C version of BME280. And this sensor is this guy right here. Let me show you the camera. Where's the camera? Yeah. So it is this sensor right here. And as you can see, it has been connected to some connection points, pins in the Controllino. And this is I2C sensor. So I will need to connect it to the interface where it is. And we'll start quickly just to see the temperature on it. So it has temperature, humidity, and pressure. And I have to connect the USB, of course. So I'm connecting the USB port, and this is COM port 5. And now we can compile and upload the code. I have connected two sensors. It's uploading. We can look at it. So I have connected two sensors. I have connected the pressure, humidity, and temperature sensor, and I have connected light sensor here. The light sensor is a simple analog light sensor. So it's uploading at the moment, compiled and uploading. Okay, the code is uploaded. And if I go to serial now and connect, we should start shortly seeing the temperature coming on it. Okay, here is the temperature. And if I touch the sensor, you will see the temperature starts rising immediately. So we have, yeah, and when I release it, it returns to normal temperature. So we have a temperature sensor. So now the idea is to send that information over industrial Modbus protocol. So I'm not going to connect other sensors and stuff like that yet. Instead, we'll start adding the Modbus functionality. So I'll search for Modbus, and the first thing we need to do is add a Modbus device. And the device has tables. The Modbus works in terms of tables, and we'll just use input registers because we'll read input analog values. And now add 4 of them. So I'm adding 4 analog inputs, and I'll start connecting the different pins with values to the different channels. to the different input registers. And the final one, if I remember correctly, my light sensor is on analog 0, so connected to analog 0. So that's it. We have the data sent to input registers. The next thing we need to do is add a protocol, and we will use serial communication for the first example. So since this is a server, we need a server Modbus protocol, and we'll use the RS-485 port because RS-485 is industrial communication physical layer, which uses just twisted pair. It's a half duplex type of protocol. So just two wires sent in both directions with differential signal. So I'll also boost the speed, so it will go a little bit faster. So I will go to the serial port communication and select a higher speed. And our RS-485 is right here. So I'll show you. So this is the RS-485, and here I have RS-485 to USB adapter. Before tariffs, you can buy those for $1 to $2 on things like, yeah, first, before we do anything else, we have to upload the code because I'm running out of COM ports and we'll have to swap COM ports. So let's start with uploading the code. Is everything? Yeah, everything is ready. So let's upload the code. May need to steal another USB power so I can power the second board when we get to it. But in any case, we're compiling and uploading the code. Come on. Yeah, it's uploading at the moment. So the code is uploaded. And theoretically, now if I unplug this USB port, plug power from the socket, and swap the USB port with the 485. Okay, so this is 485. Now what we can do is I have a Modbus tester here, which I downloaded online. There are quite a few of them available. This is, put it on the right screen. This is called Razio. And the first thing we need to do is make sure we have the right protocol selected. So it's Modbus RTU. Everything else should be fine. Yeah, the port. Let me see what COM port. It came as COM port 4. Okay, so COM port 4. It connected. And let's open, this is called input registers. And we are sending the data as floating point. And you can see all of the data. And I'll show you together with the camera. Oh, I'm sorry. I think I put it on the wrong screen. I forgot which screen I'm streaming to. Again, I'll repeat the steps. I'm sorry. So here in connection, I selected the right COM port. The Modbus is RTU, which is the serial COM port connection. Then I clicked to connect. Click here. We're looking at input registers, and our format is 32-bit floating point format. And here is the data. And I'll try to do it together with the camera, so you will see what's happening simultaneously. Okay, yeah, this should work. So now you should be able to see the data here changing. As example, I will touch the temperature and you will see the temperature rising right here. Can you guys see it?
No, I just see the code, and your product is the Visuino, the thing that you're dragging and dropping and making attachments to?
Wait a minute, am I sharing the right screen? Can you see the camera of the
No.
device?
No.
So I have been sharing the wrong screen. Well, you guys don't tell me. So let me see what screen I'm sharing. How sure I'm sharing the right screen? So let's try again. So can you see the right screen at the moment?
Yes, I see a little breadboard or
Okay.
Arduino device. I see what looks like a little device with.
With wires and stuff, right?
Yes.
Okay, so now you can see the temperature changing. Yeah, I'm sorry, it appears that I have been sharing the wrong screen and you
I
guys.
don't see temperature sharing. I see device settings. Looks like a spreadsheet.
Yes, yes, okay. So this is the design, and what we did is we added this sensor. Okay, yeah, again, I cannot repeat the whole thing over, but in any case, let's move to the next design. So at this point, we have Modbus functionality. Yeah, that's why I was expecting you guys are gonna tell me if you cannot see what I'm doing on the screen, but I didn't hear anything back, and I thought that we are sharing the right screen. Okay. What I will do is I will actually start a second instance of Visuino now, and we'll program a second device. So in this case, if the time permits at the end, I will quickly do the project again from scratch. Actually, again, since it takes just a couple of minutes to recreate the project, and I seem to have been sharing the wrong screen, I will recreate it right in front of you. So you see the new Visuino starting, right?
It says Visuino Pro.
Yeah. Okay. So this is the right screen. Yeah. Okay. Fantastic. So again, I'm repeating everything from scratch because it's that quick to do it in Visuino.
Okay.
Okay.
So this orange screen, what is that?
Pardon me?
The orange screen, what is that?
I'm not sure what thing.
On the left, you have an orange something. What is that?
Where?
On the left-hand side of your screen, I'm looking at something with orange. It says in serial. That's the device.
I'm not sure which orange screen you're talking about. Is that where I'm pointing with the mouse?
No, to your right.
Right here?
Yes. Now it's
Yeah,
blue.
this is the Arduino device.
That's the Arduino device.
Yes.
Okay.
Now it's blue, right?
Now it's blue. So
Yeah.
you plug that into your.
So this, yeah, let me explain you. This is the software representation of your device, all of the capabilities of your device. At the moment, I have selected Controllino Maxi. If I move the mouse over, you can see even hint showing how the device looks.
Okay.
So now I will add BME 280 and I2C.
And this works for any Arduino device.
Yeah, not only ESP32, practically almost any microcontroller works like. Texas Instruments, yeah, Maxim, whatever. Then I'll add Modbus. And again, I showed all of this, but since we obviously had some issue with sharing the wrong screen and I didn't know, I am repeating everything from scratch. So I'm adding Modbus device and Modbus protocol. And I'll first connect the device to the protocol, and the protocol I'll connect to the serial port. And again, you can see how fast it is, even with the slowdown from Zoom, which surely makes it slow. So I'm adding input registers, and I'm adding 4 analog input registers, 32-bit float. And what I will do is I will connect the channels to the registers. Again, literally takes a couple of minutes. And this is a very complex project, effectively, right? So you're building industrial automation device, which connects to industrial automation protocol. We are ready. We will only change the speed of the 485 protocol, because we wanted the high speed, and that's it. We are done. We have our device programs, okay? So now what we can do in addition to that, I'm not going to test it, I'm just going to quickly show it, is if I want to control relay as example, to compare with analog value. So what I can do is if the temperature rises above certain level, I can control some relay as example right here. But again, we don't have time to program and test and run experiments.
So if it goes above a certain level, you could turn on a fan.
Yes, you can turn on fan and stuff like that. And again, I use compare, but I probably should have, yeah, I'll show you another trick. So I can.
And that fan will be plugged into the Arduino or attached to the Arduino
Well, it will be one of the digital pins of the controller, basically. So I actually want to change the comparator with Schmidt trigger, and I'll replace it. I'll just select what I want to replace, and it will replace it in place. So in this case, we replaced it with Schmidt trigger, so we'll have hysteresis. But that being said, okay, let's forget about this project. I want to show you even more interesting project. So now we have our Controllino Maxi, which works over 485. But Modbus can communicate also over TCP/IP. And yeah, I can implement TCP/IP over this Controllino. And actually, just to show you how it can be done, I will do that to here. You know what? That was not planned, but I will do it. So let's first of all change our Controllino Maxi to work over TCP/IP as well. So I know this is.
Does this program the Arduino?
Pardon?
Does this program?
The device is Arduino-based device.
Does this
specifically is a base device? Yes.
Does it program it? So in other words, once you do this, could you unplug the Arduino from your computer and bring it out to the field?
Yeah, it's ready. You can put it in the field immediately. Yes.
And therefore, it would know that once the temperature hits a certain level to turn on that.
Yeah. Yeah.
Okay.
Yeah, and you can control that with Modbus, as I already demonstrated, and you can monitor it with Modbus. And again, there are HMI softwares that control over Modbus. But what I will do is I'm going to set up the Ethernet, and I have some notes here of what I need to set for the Ethernet to work. So for this specific device, it requires manual entering of the MAC address. So I have MAC address ready. I will not use DHCP for this device. Instead, I will put a IP address. And then I will need to add a socket. So add a socket, and that will be server socket. And let me take a look. For I think it was 502, the default port. Yeah, 502. So let's set a port 502. 502 port. Okay. So we are fine. And what we need to, I have not even saved the project, and we'll connect to the socket. So this is our protocol. The protocol is connected to the device, and then we connect to the socket. And let's see if this is going to work. I haven't tested it. So this is.
Do you want to change your screens? Because right now we can just see the, I'll call it a flow chart for want of a better word.
Yeah, yes, I'll actually switch to the camera.
Okay.
So see what I'm doing here with the camera. I have to upload code to the device again.
Okay.
Okay, I have to plug USB cables and stuff. So USB cables are plugged, and let me find my, yeah, okay. This is the Visuino I was looking for. So now I should be able to upload. So now it compiles and will upload the code to the device. Yeah, even with my mistakes and stuff like that, we probably will be roughly on schedule. I'm trying my best to fit within 1 hour. And again, you can see how quickly you can actually program the device. It literally takes a minute or two to build the
Boian, I have a question. Can you save that configuration so that you can program multiple of the same device?
Yes, at the moment you will need multiple instances of Visuino. For example, yeah, I will actually do a second one right here. But I'm planning to add the ability within the single ID to program multiple devices. That's not yet implemented. I simply have been too overloaded with other stuff. The code is uploaded, and let's see if it did work. So the first thing we need to do is ping the device, of course. Oh, okay. I know what I did wrong. I know what I did wrong. The device is not responding, but that's very easy to fix. I forgot to enable the IP address configuration. Yeah. I simply need to enable the fixed. I don't want to say. Yeah, the fixed IP address. In any case, what I wanted to show you while this thing is compiling, at the moment we have one device which communicates through two separated protocols. So now you can talk both over TCP/IP and serial communication with the device. Just by adding this additional component, we immediately have a new communication protocol. And of course, we needed to add, but again, that's to be expected. It's compiling and uploading. And after that, we should be able, in theory, within a couple of seconds, to ping the device. And probably already is ready. Yep, the device is live. Okay, so now that the device is live, what we can do is we can disconnect here, settings, select Modbus TCP. The port I already have set it to 192.168.0.200, and now I can connect. And voila, do you see it? The data is coming.
Yes.
And if I change, let's say this time we'll move the light sensor, and it is this guy right here. So now it's very low value. Now it's high value. That I'm obstructing it and not obstructing it. And the same with temperature. So 22 degrees, 23, 25, 27, you see it rising, and now it's going to start dropping. So now we have TCP/IP communication. So we already did a lot. But now what we will do is, let's assume that I don't want the TCP/IP communication to talk to this device. I want to talk to another device that will talk to this device. So what we'll do is we will program another controller. And this is Controllino Omega. I select the device. So selecting the device, I'll show you. So you can click on this button here. You can click on board here, or you simply can double clicking opens this dialog where you can select your device. And you can search. So we want Controllino Omega. And Controllino Omega is, let's see the camera, this device right here. So we'll use this bigger, beefier device to talk to our smaller device, and then the big device is going to talk to the computer. We will use a different IP.
Could you configure this to stream to Kinesis?
I'm not sure.
That's Amazon's data streaming platform.
Yeah, you should be able, because you have HTTP functionality. Okay. But again, yeah, I don't want to go now with configuring REST interfaces and stuff. But Visuino has JSON parsers, JSON makers. It has the HTTP client functionality. So yes, you can. I have done tutorials on that, but that's okay. That's a different story. Yeah, I don't think we can cover all the protocols in 1 hour, even with Visuino. Okay. Yeah, it's powerful, but again, I mean, time is limited. I'm trying to show as much as I can in 1 hour. Okay, so let's see, 192.168.0.201. So different port, and I need to enable. Yeah, I need to enable. Okay. So we did this. Anything else? Yeah, no, JCP is disabled, and we need Modbus, and it will be client serial. And then we'll connect that to Modbus server. So the server will be TCP, the client will be serial. They'll connect to each other. So the two protocols will basically talk to each other. So one protocol will send data to the other. The server, yeah, we need to add, for it, we need to add socket and set the port to 502. So sockets, yeah. Again, it's a server socket and the port is 502. Okay. And then this one will go into the socket. This one will go into the serial protocol. Do you see what I do here? So basically, this guy will talk to the TCP, convert that to Modbus protocol. This one will take the Modbus protocol and convert it to serial. So it's a bidirectional, basically, bridge. So I just created a bridge.
Okay.
And the only thing I need to do is set the speed for the serial because we decided to use higher speed. And this project should be ready. Now I can go ahead, connect the USB port. And yeah, we actually should be cool. So connect the USB port, select the right port. Okay, so it's on port 9. And theoretically, cross fingers, everything should work fine. So while it's compiling and uploading, I will go ahead and move the TCP, I mean the Ethernet port to the other device. And I will ping this device first, naturally. Yes?
Just curious, who's your market you're targeting? Hobbyists, business owners, people doing prototyping?
Yeah, all of the above. I target literally anybody who uses microcontrollers, anybody. So the two versions of Visuino target somewhat different market, though there is some overlap. The standard version of Visuino targets makers, beginners, artists, students, tinkerers, right? Even some people that do prototypes and projects. Visuino Pro, on the other hand, is predominantly targeting the more traditional heavy industry, like building automation, industrial automation, people that do signal processing and data acquisition and stuff like that. So again, the two versions of Visuino target somewhat different markets, though again, it's the same product, it just has different functionalities to tailor more to the specific markets. So some people that want to automate their houses, they would buy the Pro version as well, right? So nobody's stopping them. And then some companies that don't need the more advanced functionality can use the standard version as well.
Are the people in your market aware of your product?
Some of them, yeah, the product is growing in popularity constantly. And again, I mean, that Rolls-Royce was one of the first of the big companies that bought Visuino, and one God knows what they're using it for. But then there are smaller companies that have done industrial floor automations and stuff like that. There is a guy in Brazil that last year automated the entire amusement park. All of the attractions, the animatronics attractions in the park were automated with Visuino. Last year as well, another guy did a satellite prototype that was fully programmed with Visuino from A to Z. So again, there are different areas where it has been used. But that being said, we have the device program. Let's see if we can ping it. So this is 201. Yes, I have configured the device properly. We can talk to it. And now what we will do is a little bit trickier. So I will disconnect my S485 from the USB and connect the two RS485s to each other. And RS485 has plus and minus, or A and B lines as they call them, and they have to match, unfortunately, so you cannot swap them. So that's why I have color coded my wires, so I will connect the A and B properly. We need to power both devices. Okay. Both devices. So both devices are powered and they're talking to each other theoretically. Yeah, it all looks good. And now we can see whether or not we will read some data. In this case, in the settings, we'll connect to 201 device, which is the new device. And voila. Do you see what we did? In 40 minutes, while talking and stuff like that, I programmed one device to work as a controller, collect data, send it over Modbus. And then I programmed a separated device to bridge from serial Modbus into TCP/IP and send it to my computer. And
So
we
show,
did that in 40 minutes while just talking
I
to
understand.
each other.
Can you show me both devices on the screen at the same time?
Yes. Yes. You want to see the diagrams?
Yeah, the two diagrams
Yes,
together.
I will. I'll try to fit them in the screen next to each other. Come on. Yeah, Zoom is playing a lot of interesting games when you try to even resize windows when sharing, but I'm trying to open both diagrams. Okay, so this is the other diagram. So yeah, I'll try my best to show both. Come on. This guy switched to code. So I'll try to position both diagrams next to each other. I don't know how well it's going to work, but I'll try my best. So make this thing small. And I'll make this thing small. Okay, this will be sort of the best I can do, but I'm trying. So yeah, I think it will roughly work. Come on. Yeah, even switching between windows when Zoom is capturing the screen is a bit challenging. But okay, so this is roughly the two diagrams. Can you see them side by side?
Yes.
So this device, effectively, this is a sensor, reads the sensor, and there is analog line that goes here. That sensor is sent to the 4 registers of the Modbus device. And then this Modbus device, we implemented 2 protocols. At the moment, we're using only the serial protocol, but we also, for the fun of it, implemented the Modbus server protocol. And the 2 protocols are working. And the device is communicating with both protocols. So that's it on this device. And then on the other device, we have a bridge. We have this protocol talking to this protocol, and that's it. Now, what's interesting is that in the second device, I can implement Modbus. Do you still need to see both diagrams next to each other? Yeah. Okay. So now what we will do is, since we have more time, not enough things went wrong. Right? Yeah, I try my best to screw as many things as I can, but I was not that good, unfortunately. What I will do, just for the fun of it, I will show you how in this bridge device, I can have another Modbus device of its own. So add device, and it will be a second ID. So the Modbus devices, they have IDs. The ID 0 obviously is going to be the one that's bridged. This one is going to be available here. And here I'll just add a sign generator. Sign generator. Yeah, this guy. So it will send a sine wave with frequency of 0.1 hertz. And here we'll do something else. Yeah, let's do input register. Add one register. And I'll actually add one coil. So not coil, but digital input. So digital input table. And again, Modbus devices are a bit weird. They work in terms of tables and then elements in those tables. So that's how Modbus works. So that's why I have to add the table. And then I have to add elements in the table. And the elements in the table are indexed. That being said, I'll add also a pulse generator. And I'll add the pulse generator and same frequency, 0.1, doesn't matter. So I just wanted to have some digital signals. So device 2, in theory it should all work. Let's see. I can upload it. Now, as you can see here in this design, we have the two protocols talking to each other, but this protocol not only talks to this protocol, it also talks to this device. And you can add multiple devices here as well. So those are virtual devices inside the controller. So each one will have to have its unique ID, but other than that, yeah, you can have many of them. This one, I think I said ID of 2. Yes, ID of 2. Okay, it uploaded the code. So now let's see in our, I'm not super familiar, device ID. So if I said ID 2, let's see what's going to happen. Oh yeah, do you see ID 2? Only one value is changing here. Do you see that?
Yes.
Okay, if I set ID 1, it's going to connect to the other device. Come on, let's try to reconnect. Huh. Oh yeah, it's coming. Do you see the 4 values changing?
Yes.
So that means that now we have 2 different devices. Yeah, now it's this device, only this value. So I can talk to 2 different devices effectively and get their values. And if I get input status for device 2, come on. Yeah, I haven't used this functionality, but not call input. Yeah, I haven't used this functionality in this simulator. It should have. Yeah, it's reporting the input.
Could you replace this with a web-based GUI?
I can, but I have to dig out for such GUI. Do you see that input changing between 0 and 1?
Yes.
So now we're talking to the second device, which actually has digital inputs, and it has also input registers. So you can see that I'm communicating with 2 different devices, each of them having its own functionality, and one of them working as a bridge for the other one, and concentrating everything on a single interface. And I did that in 50 minutes while troubleshooting other things and stuff. Not bad at all, I think.
No, not bad at all.
Yeah, and yeah, that's why people use it. Again, no software out there has anything nearly as powerful as this and as easy to use. You can see, again, I can add another device, I can add another bridging protocol, I can bridge multiple things to multiple things. I can talk to other device right here. We still have time. Let's do one more thing. Let's try. I'm sure I'm going to break it at some point because I'm trying more and more complex things. So what I will do is I will read one value from the other device, the serial protocol. So I'm going to read one value from the other device, and I'm going to present that value as a value in this device. You see what I'm saying?
Yes.
So I'm going to read analog, not coding, but input register. Read analog. And here I'm going to add to the input registers, I'm going to add one more value. And I'm not sure which one is going to be, but most likely it's going to be the pressure, I think was the first one. Let me see. I probably can figure out. So temperature is on address 2. So you can see that it says address 2. And then we will try to read from address 2. A remote device, input range. Okay. So address 2. Oh. So I'll read from address 2, and it will come to this guy. Yeah, okay. Address 2. Perfect. Perfect. Device ID 1. Yeah, I think we're all cool. In theory. No, we're not cool. We need to clock it. Yeah, I forgot that. We need to read that with certain frequency because Modbus is a slave type of protocol. So I have to specify how often I want to read this device. And I can read it, let's say, 2 times a second. Okay, don't want to overload it. Oh, no, I don't want to see that. So again, it gets more and more complex. Now we're reading device. In this device, we're reading the other device, one of the values, and we represent it as our own value. You see what I'm doing?
Yes.
Yeah. So again, this is relatively complex functionality, and I did it in 2 minutes. So uploading. Sometimes it takes longer to compile and upload than to write the code. Just joking. So let's see if it's going to work. Again, I'm pushing the limit. So we're looking at input registers and floating point, device 2. Oh, voila. Do you see that? This is our sign generator. And this is the temperature coming from the other device. Do you see it?
Okay.
And just to show you that I'm not faking it, I'm going to touch the temperature sensor, and the temperature starts rising. Do you see it?
Yes.
Yep. Okay, I have difficulties rising it above 30. Okay, I raised it to 30 degrees. So yeah, that's the power of, and again, I dare to say that no other software in the world, aside from easy from use, has this amount of power that it can literally unleash, and with extreme ease at that. So again, there are specialized softwares that do only bridging and stuff like that, but I haven't seen software that is capable of doing this type of bridging and device virtualization and everything else. And it literally takes seconds or minutes to do this complex stuff. And again, even with AI functionality nowadays and so on and so forth, it's going to take longer to describe in ChatGPT what you want to do than literally do it right here and visualize it at that. So that's the power of the device. Yeah, we have about 6 minutes. I don't think I can probably show something, but I think now we can go to some Q&A and stuff like that, and maybe more general discussion.
Phil, you've been quiet.
No, I'm just taking it all in. I think you were the perfect audience for this. We have a lot of the good questions. I think this is a great follow-on to our first recorded session, Boian. I think once again impressed by what you've managed to create here. I was struck by Scott's question about how are you promoting this, right? Does your market really know about?
Very good question. Very good question. Yeah, thank you, guys. My problem is that I'm in general engineer and nerdy engineer at that. And furthermore, nerdy, slightly autistic engineer. Okay. So that being the case, I'm not a salesman. I'm horrible salesman, right? Yes?
See, now, my father was like that. Brilliant electrical engineer, probably. I was told by other people that when he was alive, he was probably the top 5 or 6 in the country. He once gave 4 abstracts at IEEE. And for a one-man company, that was amazing. But I am a salesperson. I am an engineer, not on your level. I understand what you're doing. I understand all the things. But I'm too slow trying to code all that. I see the potential of this, and I see and the real money has got to be with industrial people, not so much the hobbyist.
Yes.
Because the hobbyist likes to go through and throw dip switches almost. Many moons ago, I was working for my dad. We had to do program EPROMs, and he set it up so you put the EPROM in, hit a button, and the EPROM was done. And he pulled it out and went to the next one, and that saved so much time back then. And that was the way in the beginning. We had ARPANET. That was about it. That was in the early days, but mini computers were not even out yet. But I can see this as doing things. When there's when I ask if you can step and repeat, that's good for manufacturers. So like I was saying with the EEPROM, you should be able to put one in the device, hit boom, and it programs. Boom, and it programs once you get the first one done. I remember, God, this must have been like 98, 99. I had to set up like 40 computers. I borrowed my friend's hard drive cloning. That was the first one. You just put the hard drive in. Once you perfected the hard drive with the OS and everything you wanted, you would then put in the device and put 6 ones in, hit a button, and come back an hour or 2 later, and all the drives would be exact copies of each other. That's how you get performance up there, and that gives you a different market. A hobbyist market means you have to hit all the maker shows and so forth and pair it with Arduinos. And if you just show it to them, you might get some, and you put a kit together with Arduino in it. The trouble is it moves so fast that by the time you package an Arduino, get it on the shelves, it's already obsolete. So you would have to be an Arduino store that sells this with it, with the last Arduinos. I know you're doing that to some extent, but you really have to push towards that. But I don't know how big of a business that is. I don't know what your goals are.
Yeah,
But
my goals are in general to get it into the hands of everybody worldwide who is programming controllers, being professional, being industry, be it a hobbies and stuff. And
are you looking to become? Are you looking to keep this as a hobby that throws a few bucks, make a living, or make a fortune? They're all good.
well,
They're all good things. There's nothing wrong with any of them.
yeah, I am trying to make money out of this, but I also try to, again, so I have seen so many people struggle with embedded programming and programming the devices and stuff like that. I want to change the life of those people. At the same time, I definitely need to grow this thing and to turn it into a business. And I don't see an issue of achieving both goals. Again, I agree, priorities have to be changed. And yes, if I can find the right partners, I will go to a big push for the industry. For me, unfortunately, I have not been able to find the right partner for that. I have found a partner who is helping me to push it more into the maker space, and that's what I'm doing, and it generates revenue. But definitely, if I can find the right partner to push it into the industrial environment more, that will be fantastic. And yes, I'm open to partnerships. And that being said, I also offer it as, I mean, for white labeling. There is a company in Australia that I have developed a special version of Visuino. They built industrial controller devices. I actually have one of them right here. These devices, they come with special version of Effectively, which programs them, and they label them as their own product and stuff like that. They pay me royalties. So yeah, I'm open for that one as well.
Gentlemen, I think with that, we're at time.
Yeah.
And I think that was a perfect discussion to close out the session, because one of my goals of my involvement in the group here in Alignable